Good afternoon, everyone. It's 2:10. I think we can begin now. So in last class, we were talking about, let me see if I'm audible or not. I think I am. It's sharing and started recording as well. Okay. So last class, that was, I think, yesterday, we were talking about the raster encoding, how raster gets encoded. So, excuse me, there are 4 ways. The first thing is to identify or to encode any data which is object-based data. For example, if you can see here that this is a river maybe, or it's a path, and this is an object phenomenon, not a field phenomenon. So to encode this, what raster does is it only identifies the cells that the path goes through. For example, in this example, the path went through these cells, and that's why only these cells are highlighted. And if you look into this cell, it seems like that the path is not really touching this cell, but it is. It's sort of going through. If we can draw this in a large extent, that this is our cell, and the path is crossing just like that way. Okay, so since the path is overlapping or going through this cell, so that's why this cell is also identified as a path. So in this phenomenon, what happened actually is it's just presence and absence. So in this cell, the path is present, and in these cells, the path is not present. So we observe a phenomenon where the raster is encoded based on the presence and absence of an entity or an object. Another example could be dominant type. So what is the dominant type of the entity or the classes in a pixel? So if it's a real life scenario, and in this real life scenario, we might say that this is bare land since this color is colored as brown. And we might say this is vegetation since this is green. So let's say, let's assume that this is two land cover types. One is bare land, another one is vegetation. And in this example, you could see that based on the dominance, based on the presence inside a cell, we could see it was mapped out into 2 classes in the raster image. So all these pixels, they turn into green, and they denotes or they identifies or they represent a vegetation class, whereas these pixels, they are now identifying or representing a bare land class. And then if you want to be more precise, we can also say that, all right, so this is the line, the border line of these 2 classes. So we could say that, all right, so this is the border line. So that means in this pixel, we have mixed classes. That means in this pixel, we have some of the areas which are bare land, and we have some of the areas or rest of the areas in a single cell which belong to vegetation. So that's why we could say that these are mixed classes. I mean, these pixels are representing mixed phenomena, whereas these pixels, they are absolutely vegetation, and then these pixels are absolutely bare land class. And the third one that we can talk about is the percentage of occurrence. So in a polygon, we have the same polygon, and if we want to represent it, we can say, all right, so this class is bare land, this belongs to A, and this is vegetation, this one belongs to B. I mean, in this line. So if we think of that, so percentage of occurrence in this pixel of bare land is 60%. So since this is 60%, then we can say, okay, so this is one single raster where the bare land is occurring 60% in this region. And then we could say, okay, The 40% of this entire raster is vegetation. So these are the vegetation, and these are the these 40% pixel in this cells. The 40% is the vegetation. So vegetation and then vegetation of the 40%. We now have another raster. Okay, and then we have bare land, and then 60% of the cells are bare land. So we have another raster layer which is bare land. So essentially, what we are having is we are having two raster layers, which are creating or which are created from a single layer of vector data. And then finally, we have another encoding process, which is called centroid of cell. So in this example, we have a cell, and then we only consider what's at the center of this cell. Okay, so that's the center. We only consider what's at the center of this cell. So if at the center, if this is vegetation, this entire cell is going to be vegetation. If the center of this pixel is located at any bare land, then this entire pixel will be bare land. One quick, very good example would be these two pixels. One is this location, located in this location. And another one would be located at this location. So in these two pixels, you could see that the centroid of the pixel is located just outside boundary of bare land, and that's why these two pixels, I mean this one and this one, they became vegetation, because although a large percentage of these pixels belongs to the bare land class, however, the centroid of the pixel of the cells, not the pixel, or the cells are located at the vegetation cover. So that's why in the result, we can see that these pixels, they belong to vegetation class instead of belonging to centroid class. Whereas in these examples, the bare land is the dominating one. It has the more cells, it's covering the more cells. Whereas in this example, because of the centroid encoding, now the vegetation is covering more cells than the other examples. So which one should we use? Well, there is not really any shortcut answer. There is not any binary answer that, all right, this is the best and rest are not the best. Okay, it depends. It depends on your study. It depends on what you are doing. So or which software you're using. Based on all these multiple factors, you will be using a certain raster encoding in your study. And then what could be inside a cell? We have already seen, and we have already said in previous examples, that a cell could contain a value of integer, or it could be a value that is a numeric. It could contain a value of alphabetic, or it could be mixed, that is alphanumeric values. So here are more concise examples of these values. The first one in the integer is the integer. In integer, so all the numbers are full number, that is 1, 2, 3, 4. So for example, if you want to find out that, all right, so these are the numbers of bird sightings in each pixel, that means I have seen 3 birds when I was in this pixel, that means I was in this area. Or I could say that I have seen only 1 bird when I was visiting this cell. That means in reality, if this is 30 meters by 30 meters, if I draw this quadrat at that moment, I can say this is a quadrat cell. So if the boundary is 30 meters by 30 meters, and I was standing at any point of this 30 meters by 30 meters boundary, I might have seen only 1 bird. So that's why I put only 1 value in this cell. And then now let's talk about elevation. And elevation doesn't really jump from 1 to 2 meters. instead, what it does is it changes in a continuous scale. And since it changes in a continuous scale, we will be seeing decimal values. Okay, so in the decimal values, that's why we might say that, all right, so all these pixels, they belong to the 2, but they are more than 2, they are 2.2, so they are above 2.2. So 2.2, 2.2, 2.2, 2.3, 2.3, and goes on. And all these pixels, they are less than 2 meters. So they are, for example, 1.7 and 1.8. And all these pixels in orange, they belongs to the group which ranges from 2 to 2.2 or less than 2.2. More than 2, or sorry, from 2 and less than 2.2. So that's why we are seeing only 2.0, 2.0, 2.0. We might have seen sometimes 2.1 as well. And if these are not numeric value, then we could have something which is non-numeric or alphanumeric. And these alphanumeric values, for example, they could be land cover classes, vegetation. Okay, it could be vegetation. For example, in our previous, let me fire up that one. Okay, so my ArcGIS has stopped working. What's wrong? Right. It's keep crashing. Anyway, so yesterday's example, you have seen that the land cover classes that we have seen, it had vegetation class, then built up area class. And when we clicked with the identify tool, when we clicked on a pixel, it told us that this class belongs to others, or this class belongs to built up, or this class belongs to vegetation or bare land or something like that. So that's how, and that value is a alphanumeric value, or we could say that, okay, so there is no number, so that value is a non-numeric value. Okay, that means that one is containing only the alphabetic types. So furthermore examples you have. So just a wrap up, quick wrap up, we have cell, which we usually say pixel in raster. They have width and height. Normally they are in square shapes, but sometimes they could be in rectangular shapes as well. Maybe in future you might encounter any circular shapes as well. I don't know. I have never seen one yet, but could be. So one quick easy way to identify a cell is that if you have one area, and then if you divide this area into equal size of cells or grids, I mean, if you draw multiple lines having equidistant from each other, okay, then you will encounter, or you will create these small pixels or small boxes, okay, of cells which are known as pixels. So that is what happened here. We have one area, and then we have divided these areas into columns and rows with having the same distance in both height and width. So if we divide it finely, if we have less amount of distances on both height and width, then we get fine resolution. If we increase the distance a little bit more, then we have a medium resolution. Then we have, and then if we increase the distance even further, then we might have something coarse resolution or very low resolution. So if this is a lake, then this lake is almost, it has identical boundary with the reality in this raster data. Almost, I said almost, not exactly. But then if we increase the distances between these or the sizes of the pixel, then we have something which looks like this, but not entirely represents the boundary of the real entity in reality or in vector. And if we increase more, at that time, what we can see is, or we can only identify the presence of this entity and nothing else. This is no way is the shape of this leg, because the leg does not look like this, of course. Okay. In any way, we could say that this legs has a shape of something like that. I mean, if you draw something like that, that's the leg, but then that would be represented by using this sort of pixel. So instead of having this shape, it's had even further. It has a leg or extension in this area. So that's why we could say that, all right, so in this raster, this is it does not represent this leg. I mean, it does not represent the shape in any way. However, it does represent the presence and absence of the leg or the entity. Okay. So that's the representation of it. That is totally representation, nothing else. Okay. So what's going on at the background? At the background, what we see is these numbers. We're having this matrix of numbers arranged in columns and rows, and they are representing that, all right, so this is what's going on at the background. These are the numbers that we are having, and to identify the leg, we might have to go through these values which are quite low. For example, 45, 45, 34, 45, 34, 45, 34. Or we could say, we might say that, okay, so only the values which are less than 40 represents the leg. So in that case, we could say that, okay, in this example, only these values are representing the leg because they are less than 40. Okay, and one might say that, okay, it's less than 40, but it's less than 30 as well. So if it's less than 30, sorry, more than 30 as well. So if it's more than 30, then we have to exclude this pixel. So at that moment, we are having an example, which is the leg is identified with these values, and rest of these belongs to something else. Okay, so this is how, mathematically speaking, or data-wise, this is how raster looks like at the background. Okay, but representation-wise, this is data-wise. Data or mathematics. And representation-wise, this is representation. Representation-wise, this is how raster look like. All right. So sometimes these values, these 3, 4, 3, 9, sometimes they could, I mean, the value that raster contains, sometimes it not only just a number, this is also the height that it means. That means in a pixel, you have width and you have height, but this height is the height in a two-dimensional form. Okay, so in a way, we could say that, all right, this is not height. This is not height. Oops. We could, in a way, we could say that this is not height. This is actually length. Okay, this is actually length. So we have width, length, and then now we are going to have height. So there you go. This is height. So this is height, right? So in this example, that is exactly what happened. So every pixel, they are in square shape. So that means they have both sides, or all four sides are having the equal length. Now, some pixel, it says that it's 35, and some pixel is 20. So these 35, 20 are actually representing the height of these pixels, each pixel. So this is 20 means, all right, so the height of is 20. And 20, again, this is 20. So let's go 20 and 35. So this is 35. and now 50. So all this, if I think of that, so that's 50. Okay. And this is very important. Why is it very important? Because using these characteristics, we identify DEM, digital elevation model. We can use raster image to represent the heights. We can map the the terrain. How do they look like? So I can show you something. I'm going to share my entire desktop, and then I'm going to fire up the Opera, and I will search for MapMaker David. Okay, so MapMaker David, there you go. So he's a famous guy who works on OpenStreetMap, and he creates multiple maps, mostly in Pacific. He's from Indonesia, if I'm not wrong, or maybe Philippines. Okay, so see, these are the raster images which are representing the terrain. So these are DEM, digital elevation model. By looking in this image, you can, of course, you can see that, okay, so this is flat, maybe this is the sea, and these are the mountains. Okay, these are the mountains lines. So another one, it's more detailed. So these are the mountain lines, or and then this is the seabed. Okay, so yeah, raster can be used from that perspective. Okay, from in that way. However, okay, we will talk about it later, not now. Yes. So in this example again, once again, raster, if we look into raster, you might see, so this is the, you might see something like this. If these are the lines, these are the vector lines of, if these white lines, they are the boundaries that exist in reality. In raster, you will have these red cells or pixels representing this area. And then we have these purple color cells representing this area, which does not really represent the exact boundary, but it represents the existence or presence of them. And when I go to the matrix of the number, we will be looking into something like this. We have this 1, 1, 1, which is this brown color, and then 2 the blue color, green is 3, red is 4, and then 6 is the purple, and then again here deep brown one is 5. Okay, so 1, 2, 3, 4, 5, 6. We have 6 classes. But then when you go to the database, okay, in database it will look like this. It will look like row and column and value, and then V2. Okay, so this could be the cartographic information of which color that we are representing for these specific values. So these are the ones. So row 1, column 1 is 1, row 2, column 2 is 1, row 3, column 3 is, column 1 is 1. Okay, so we go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 is green. So row 8, column 8, sorry, column 1 is value 2. So we have these 2. Okay, and if we go, all of them are 2, and then suddenly it became 3. So what's 3? We have a 2 here, and 2 belongs to the water, the blue line. Okay, so we have a blue line here, and then we have this 3, 3, 3, 3, 3. Everything is green. Okay, so we have from here we have 3, and in the color scheme, in the cartographic information, that is, we can see we have 500 for all these cells or pixels, then 507 for all these, then the value starts changing. Okay, and then okay, so the grid databases. So for all these grids, you could have multiple layers of individual grids. Okay, for example, for roads, you could have one layer, just like vector, just like what you have seen previously in ArcGIS. You could have one layer. You could have soils in a different layer, boreholes in the different layer. However, you have to remember that each pixel, they are located on top of each other. So if I just draw a single line, so this line is going through the center of all these pixels. Okay, so just like previously I said, now you can do multiple, I don't know, mathematical operations. For example, you can add them up, you can add the values up, because since these pixels are incidenting on each other, exactly on each other, they're falling on each other exactly. So you can concatenate or add them, you can divide them, or you can multiply them, or you can do something else. Okay, maybe not division, not a good one. Okay, I cross this one out. Okay, maybe subtract them or do something else. Okay, you can do multiple operations. However, whenever you are doing that, only one cell from each layer is activating. Okay, but then the computing is so fast that we do not really see that, okay, so the cell 1 is working, cell 2 is working now, cell 3 is working now. That means if this is cell 1, then this is working now. If this is cell 2, then cell 2 is working now. We do not see that this is 1, 2, and then this is cell 3, and this is cell 4. This is, yeah, we do not see that. Okay, we see that all at once they worked and they get represented. Sometimes you will see in our ArcGIS that little globe is rotating at the bottom. That means it's working, but at the end you will see your final product just at once. Okay, just like this, just like some laser printers that we have today. In laser printers, you click print and then it comes straight away, right? But just go back, for example, 15 years, then we had this printer where everything get printed in a line by line. Okay, and in 2207 you have also seen these printers, or we were saying that's the per line printing. So now this grid cell data types, I mean, in vector we know that we have point, line, and polygon, right? So let me just write down here. We have vector, and in vector we have point, then we have line, and we have polygons. Okay, so and polygons. In raster, however, we have, instead of saying a point, we say punctual. Okay, or in vector as well, you could say punctual. So essentially, this is actually point, right? And this one is actually line, and this is polygon, and this is simply contours. So when there is a line in grid cell data, only one pixel would be, so this is not really an ideal image of that. So I'm just gonna draw one little thing here. So if this is the punctual, so this cell represents this point. So this is called punctual, and this is 0-dimensional. This is the important thing from this slide. This is 0-dimensional. It does not have any dimension. It just has a presence. It just has a pair of coordinates. That's it. It doesn't have any length. It doesn't have any width. It doesn't have any height. It might have some temporal information. It might have time. If you consider time as a dimension, then it could be, from that perspective, it could be 1-dimensional. But then in these basic definitions, we do not incorporate time. So this one is 0-dimensional. It has nothing. Okay, it's just a point, a dot. That's it. All right. So we call them 0-dimensional. And then in linear, we have raster like this. And these rasters, maybe the line went through this way. So we have this linear fashion, all right? And in these lines, they are one-dimensional. Both in raster and vector, they are one-dimensional because they have only length, how long they are. So from these pixels, you might calculate, all right, if this is 30, 30, and 30, so they are 30 plus 30 plus 30. Okay, 90 meters. But then in reality, it went diagonally, so this is not really 90 meters. But then this raster is not the exact representation of reality, so we have to accept that. By accepting that error or bias, we can say, okay, so this is 90 meters. Okay. Now, another dimension is the two-dimensional, which is the aerial, or in polygon, sorry, in vector, we say them, we identify them as polygon, and in raster, excuse me, we could have something like this. So maybe these classes, they belong to one class, and these classes, they belong to another class, and then these classes, they belong to another class. So you have three classes. All right. So in these classes, what we have is, now they are aerial. We can measure area. How? You say, okay, so this is 30 meters, 30 by 30, and this is 30 by 30. So it's 30 square meter plus 30 square meter. Okay, do you understand what I'm saying? So 30 times, sorry, let's, for the simplicity, let's say it's 3. Okay, the cell size is 3. So we have 3 times 3 plus 3 times 3. So 9 plus 9, 18 square meter. Okay, then we can say, all right, this is 18 square meter. In Polygon, however, what we can do is we can simply use the geometric calculation or calculate geometry. There are tools available in ArcGIS, QGIS. All you have to do is right click and select calculate geometry, and automatically using the coordinates, it will find out what is the size of this area in a vector data. Okay, the software. In raster, to do that, I mean, there is no direct way, but there are indirect way. What you can do is you can use zonal statistics. So zonal statistics. You can say that, all right, so this is my zone, and this is another zone, and this is another zone. Now calculate the size of these zones. Okay, so based on the zones, zone 1, zone 2, and then zone 3, it's going to calculate the statistics of these pixels. And from these statistics, you can find out the sum of this pixel, and then you can find out the sum of this pixel, that is the sum of their area. You can find that one out, or even the most primitive way to do that is to find out how many cells they have. So if the cell is, let's say 1 and 2, if there is 2 cells for class 1, then 3 cells for class 3, and then 4 cells for class 4, then we can say that, all right, it times 3 square. So 3 square is 9, right? তোমরা কি আমার কথা শুনতে পাচ্ছ? It's awfully silent on your side.
Yes, sir.
Okay, that's good. So there is 9. So you can now say that, all right, so 9 times 2 is, and this is actually what I have done when I was doing my bachelor. আমার ব্যাচেলর করার সময় আমি আমার land cover class পেয়েছি. So for each classes from this land cover map, I calculated the pixels. When I calculated how many pixels, and ArcGIS automatically do that. So after calculating the pixels, I brought them into spreadsheet, that's Excel, and then in Excel I automatically calculated how many. So Landsat is 30 meters by 30 meters. Okay, so that is 900 square meter. Okay, so 900 square meter times then multiple values. So in this case, if they are 3 by 3, okay, so that's 9 square meters. So we can say that, all right, 9 times 2 is 18, and then 9 times 3 is 27, 9 times 4 is 36. Okay, so this is the area of my different classes. Whereas in Polygon, you can directly calculate the areas. Now we have this superficial. So as it says, it's superficial. So it works with surfaces. All right. So this is 3-dimensional, but then this is not 3-dimensional. So let me clear this slide first. So the superficial data type, they are 3-dimensional, but then they are not 3-dimensional. And what do I mean by that? Do I have anything on 3D? No. And to understand this 3-dimensional and 2.5D, 2.5-dimensional, you have to understand something. 3-dimensional is something which is filled out, which is not empty, which is not surface, for example. Okay, so all of you had these conical birthday hats, right? ছোটবেলায় কি এরকম হ্যাট পরে বার্থডে সেলিব্রেট করেছো? অনেকে করেছে?
Yes.
এখন now maybe still do, some of you, and then also some of you had these ice creams in cones, right? We have this cone, and then it's empty inside. All it has is the surface of it. So in the birthday hat, so this is hat, and this is okay, ice cream cone. So all of them, they have only the surfaces, nothing inside. It's void, it's empty inside. So these are known as 2.5D. Okay, but now, for example, even on the street, you will see some things, these which are, you know, giving you a warning that you cannot, this road is blocked. So we use these cones to block the roads. And now, for example, let's say we are talking about something. Okay, so tennis ball, another example, or any football. So what's inside a football?
Sir, bladder.
I mean, what's inside that bladder?
Air.
Air. There is nothing, right? So just imagine you, I mean, okay, let me give you an example with tennis ball instead, because football is too big. Okay, and if things get very big, it's sometimes they are difficult for us to understand. So tennis ball, what's inside a tennis ball? Air, right?
It's empty. Air.
Same thing, air, right? So if you now chop a football, this is a football or tennis ball, and if you chop half, okay, take half of it, and this thing is quite common in tennis balls. They get into two very often. তারা যখন ফেটে যায় দুই ভাগ হয়ে যায়। Okay, যারা বোম বাস্টিং খেলেছো ছোটবেলায়। So anyway, so football, if you chop it, okay, if you cut it half, make two equal half, then you will find that মানে চুপসে যাওয়া ইংরেজি কি হবে? তারা চুপসে গিয়েছে। So it's very difficult to explain sometimes, but think of this as tennis ball, and then you cut it into two halves, okay? And one half, you will see that it's staying just like this. I mean, it's a dome. It creates a dome just like that, okay? And if you place it on a surface of Earth, then it will create a dome, but inside it's empty. There is nothing. Okay, there is nothing inside. It's just empty. So all it does is it represents a surface. Okay, something like globe. The globe that we have seen on our table, the globe that we have seen in our school days, inside that globe, there is nothing. It's just surface. Okay, so on the surface, let's say, for example, in this tennis ball or here, in this surface, it has width, it has length, okay, and then this one is the surface. So it has height, okay. So this is the length and width. If you can represent this tennis ball in a two-dimensional plane just like this, then this is the width and the length or the height. That is what width and height I'm talking about, or width or length I'm talking about. But then just imagine that this is the tennis ball and this is your land surface. And you are trying to estimate the height of all this, or you are trying to measure the height of all this, just like an igloo house maybe. All right. So every igloo house, they have a height. And now imagine there are multiple lines. You have drawn multiple lines, and these are the height lines. I mean, these are the scales where you can calculate the height, and you will find that this surface will be intersecting them only once. Okay. তারা এই লাইনগুলোকে, হাইটের লাইনগুলোকে আমাদের এই বলটা, সারফেসটা শুধু একবার করে ছেদ করবে, মাল্টিপল টাইমস ছেদ করবে না, বিকজ বাকি জায়গাগুলোতে সে হচ্ছে কি খালি, কিছু নাই, ইটস এমটি, ইটস এয়ার। ওকে, কাজে সে তার সারফেস অনুযায়ী একবার করে তার ছেদ করবে। তার মানে দিস object has only one h at any point, that is one height. যে কোনো পয়েন্টে, let's say if we think about this point, it has only one single height. If we think about the next point, it has only single height. কারণ সে ওই স্কেলে, অর্থাৎ এগুলো যদি স্কেল হয়, প্রতিটা লাইন যদি স্কেল হয়, ওই স্কেলে সে একবার মাত্র একটা জিনিসকে ইন্টারসেক্ট করছে বা ছেদ করছে। Okay, so it has only one height. At the same time, it has multiple, the width and length throughout its surface. So we have height, but that's only once. Okay, that's only once. শুধু একবার করে প্রতিটা পয়েন্টে, প্রতিটা কোঅর্ডিনেট তুমি যদি ধরো, এগুলোকে কোঅর্ডিনেট পয়েন্ট ধরো, তাহলে they have only one singular h value. Height once, then we have, of course, have length and width. So these are called 2.5D because they represent the surface. Okay. So in this example as well, all these images.
I have an example of 2.5D.
Okay, bolo.
Sir, there is a game called Mario.
Yes.
So there is a new game which is known as the new Super Mario Bros. So that game is actually built on 2.5D scale. So from that we can actually get some idea.
Okay, so maybe everyone can start playing what? New Super Mario Bros, right?
Yes.
I haven't played that. I played Mario when there were TV game. Those weren't even today's PS3 or something. At that time, the games used to be just like cassette players. There are small cassettes, and you put it on the machine, and then you play. So that was the last time I played Super Mario or Super Mario. Now that I think of it, I feel that I'm very old, very older than you guys. Okay, not a good feeling. So now, then the question is then, what is 3D? What is three-dimensional? So three-dimensional is something sort of like গোলক নিক্ষেপ কে কে খেলেছো যখন স্কুলে ছিলা, কলেজে ছিলা? গোলক নিক্ষেপ
স্যার আমি
Yes,
sir.
3D would be easy, sir, with swimming, sir.
স্যার থার্ড হয়েছিলাম স্যার একবার।
Sir, 3D.
জি স্যার।
Congratulations.
Sir, 3D can be explained with swimming, sir, actually, easily.
Yes, okay, explain.
Sir, like where are we now? When we are in land, what we can do is we can go forward, backward, and sidewards. The movement is only two like in two directions. But when we are swimming or when we are flying, we can also go forward, backward, right, left, and up and down. So we have 3-axis movement. So this 3D is actually this kind of space that where movement or any object can be viewed from any angle.
Okay. Yes, that's also another explanation of 3D. Okay. But then this 3D is sort of like it's an example of 3D from the real life. But we are now here talking about a little bit data, because if I give you your example, then one might say that, okay, so if this is the surface, so at any point I'm changing my height, which is the elevation. Height is in this way. Okay, I can go, and in this plane I can go left or I can go right. So that means I'm also moving three-dimensionally, because in water you are changing your height, and when you are climbing a hill you are also changing your height. So you are changing your height, and then at the same time you are moving forward or you are moving rightward. Okay, so that's why I'm saying this 3D is a little different. So every hills, they are actually, say this hill, this is three-dimensional. How it's three-dimensional in GIS? Because if you think about this hill and if you point a stick in it or point a scale in it, then you will find that, all right, so this is 30 meters. The elevation is 30 meters at this point, but you can also calculate elevation at any point of these areas. Why? Because this is solid. This is not filled with air. Okay. Whereas if you go to this tennis ball, you can calculate height only at a single point. For example, if you want to calculate, if this is the scale that we are talking about, then you can calculate only at this point. Okay, so at this point, this is, for example, 3 inches. Excuse me, the height is 3 inches. Okay, but then you cannot calculate all these points below these 3 inches because there is nothing. There is no object. It's just empty. Okay, so that is the 3 dimension. So গোলক নিক্ষেপের ক্ষেত্রে টেনিস বল যখন ছুঁড়ে মেরেছো, টেনিস বল is a superficial. It's 2.5D. I mean টেনিস বলকে যদি হাফ করো, okay, but গোলক নিক্ষেপকে ছোড়ার পরে এখন সৈকত যদি মনে করে যে ঠিক আছে গোলকটা আমি বাসায় নিয়ে গিয়ে আমি এটা করাত দিয়ে কেটে এটাকে 2 ভাগ করব, 2 ভাগ করার পরে তারপর আমি দেখব, then that sphere would appear something like this. It's solid, and then you could have multiple heights in it. তুমি একদম সেন্টার বরাবর একটা ফুটা করলা, ফুটা করে এখন তুমি ওই জায়গায় মাপছো, তুমি দেখবা যে you have multiple because there are objects, there are metal inside. Okay, so কোনো কিছু যদি ভরাট হয়, okay, if then the object is solid, we say 3-dimensional in raster. Okay, but then if it's not solid, if it's only representing the surfaces, we call them 2.5-dimensional, just like this tennis ball, or just like these, where are they? Just like them. Okay, so in these examples, in this digital elevation model, you will find that this one at the bottom of this surface there is nothing, it's empty. Okay, so it's sort of আমরা ওই যে ইউরোপে একটা সময় লোক মারা গেলে তারপরে লোকটার মুখের ছাপ নিত, এটা জানো? হিস্ট্রির একটা সময়ে একটা সেগমেন্টে ইউরোপে যখন লোক মারা যেত, নোটেবল যে পাবলিক গুলো ছিল, এক্সকিউজ মি, তাদের কি করা হতো, মুখের ছাপ নেওয়া হতো। মুখের ছাপ নিয়ে পরে তাদের ওই মুখের ছাপ নিয়ে তাদের একটা মাস্ক বানানো হতো, যেটা হচ্ছে তারা তাদের ইয়াতে দেয়া হতো, কি বলে এই যে সমাধি যেটা থাকে, তারা তো ওই সময় কবর দিত না, দে ইউজ টু হ্যাভ দি স্ক্রিপ্টস। ওকে, ওই যে বাক্স বাক্স করে গেম অফ থ্রোনস এর মতো, ওকে, ওই জায়গায় রাখা হতো। সো ওইখানে তখন তাদের মূর্তি বানানো বা সমাধির ওখানে তার ওই ফেসটার ওই ছাপটা বসিয়ে দেওয়া হতো। সো ওই ফেসটা যখন ছাপ নেওয়া হয়েছে তখনও দেখো আমার ফেসের যদি আমি ছাপ নিই, I mean still people are taking the impression of their faces, then hands and so on, right? Now we have multiple chemicals to take them, multiple plasters, multiple type of plasters to take them. So ওগুলো যদি দেখো তাহলে ওখানে কিন্তু কি হচ্ছে, সুন্দর করে আমার মুখের ছাপ বসিয়ে দিচ্ছে, but then inside is empty. So that one is superficial. It's only replicating the surface of my face. আমার কথা বুঝতে পারছো? শুধু আমার মুখের সারফেসটাকে তারা রেপ্লিকেট করে নিচ্ছে। তো ঠিক সেইভাবে এখানে যে জিনিসটা হয়, since the satellite signal or any signal cannot penetrate the soil or the surface of the terrain, it takes or it represents only the surface of it, and it keeps what's below the surface as empty. And যখন আমরা এটাকে দেখি উপর থেকে তখন আমার কাছে মনে হচ্ছে যে অলরাইট দিস ইজ, আমি তো সলিড কোন একটা জিনিস দেখতে পাচ্ছি। ঠিক সেইভাবে কিন্তু তুমি যদি এরিস্টটলের মুখের ওই ছাপটা দেখো তাহলে তোমার কাছে মনে হবে তুমি এরিস্টটলের মুখ দেখছো, বাট মুখ এই মাস্কের পেছনে চলে যাবে, ইটস এমটি, দেয়ার ইজ নাথিং, বিকজ এরিস্টটলস ফেস ইউজ টু বি দেয়ার। ওকে, ঠিক সেইভাবে তোমার মুখের ছাপ নিলা, পেছনে আর কিছু নাই, ওকে, বাট সামনে থেকে দেখলে মনে হবে যে আমি তোমার দিকে তাকিয়ে আছি, বা আমাকে দেখলে তোমার মনে হবে তুমি আমার মুখের দিকে তাকিয়ে আছো। So just like that. So DEM, digital elevation model, works just in the same way. Okay, so that's why in raster there is hardly any three-dimensional object or three-dimensional data type. It's mostly 2.5 dimensional. Okay, and in vector there is actually no three-dimensional, because vector is represented with, you know, there is point, line, and polygon. So how can you represent something solid with these types of data? It's quite impossible. The maximum or the most you can do is you can represent the superficial or the surface using these control lines. Okay, so here goes another difference between vector data type and raster data type. So that's all for today. We will be catching up from these things from next week.
Sir,
Don't have any question.
sir,
Yes.
কোন ডেটা টাইপটা বেটার ইউজের জন্য?
ইউজের জন্য, ব্যবহারের জন্য?
জি।
There is কোনো বেটার ডেটা টাইপ নাই। I mean, it depends on তুমি কি করছো। তুমি যদি এখন কথার কথা তুমি যদি বলো যে আমি নেটওয়ার্ক অ্যানালাইসিস করব, অর্থাৎ তুমি আজকে আমাকে বললা যে স্যার আমি প্রতিটা বাসায়, ঢাকা শহরে যে বাসাগুলো আছে ওই বাসাগুলো থেকে আমি ফায়ার রেসপন্সের ম্যাপ করতে চাই। অর্থাৎ তুমি তোমার একটা স্টাডি গবেষণা করছো বা একটা টুল ডেভেলপ করছো, সোজা কথা একটা অ্যাপ ডেভেলপ করছো, যে জায়গা থেকে লোকজনকে বলে দিবে যে ফর এক্সাম্পল তার বাসা থেকে নিয়ারেস্ট হসপিটাল কোনটা, ফায়ারের ওই এক্সাম্পল বাদ নিয়ারেস্ট হসপিটাল কোনটা। ওকে, সো এই ক্ষেত্রে তুমি কি করছো, এই ক্ষেত্রে তুমি কিন্তু জাস্ট তোমার রোড নেটওয়ার্ক নিচ্ছ, তোমার হসপিটালের লোকেশনের ডাটা নিচ্ছ, আর ইউজারের কাছ থেকে তার বাসার লোকেশন অর্থাৎ তার ফোনের কোঅর্ডিনেট নিচ্ছ, পেয়ার অফ কোঅর্ডিনেট। ওকে, সো এই ক্ষেত্রে তুমি রাস্টার দিয়ে তো কাজ করতেই পারবে না, ইউ হ্যাভ টু রিলাই অন ভেক্টর। ওকে, সো ভেক্টরের যে রোড নেটওয়ার্ক ডাটা আছে, সো পয়েন্ট হচ্ছে তোমার হসপিটালগুলো মাল্টিপল পয়েন্টস, এন্ড দেন তোমার ফোনটা যেই জায়গায় আছে তার কোঅর্ডিনেট আরেকটা পয়েন্ট, ওইটা হচ্ছে তোমার ওই পয়েন্ট থেকে তুমি নিয়ারেস্ট পয়েন্টে যাচ্ছ। এখন নিয়ারেস্ট পয়েন্টে যে যাবা, লেট মি ড্র সামথিং, তোমরা তো স্টিল আমার স্ক্রিন দেখতে পাচ্ছ, রাইট? সো এটা হচ্ছে তোমার ইয়ার লোকেশন, ইউজারের লোকেশন, এগুলো হচ্ছে হসপিটাল। সো দিস আর দ্য হসপিটালস দ্যাট ইউ হ্যাভ। সো এই চারটা হসপিটাল তোমার কাছে মনে হতে পারে যে অল অফ দেম আর লোকেটেড 1 কিলোমিটার অ্যাওয়ে ফ্রম ইউ। সো তারা কিন্তু সবাই তোমার থেকে সমান দূরত্বে আছে, তাই তো? 1 কিলোমিটার, ডিরেক্টলি 1 কিলোমিটার দূরে আছে। সো এখন তোমার কাছে মনে হতে পারে যে ওকে আমি 1 কিলোমিটার গেলে তো যে কোনো একটা হসপিটাল পাবো, বাট ইন রিয়ালিটি ইটস নট রিয়েলি দ্যাট ট্রু। কেন? ইউ হ্যাভ টু থিঙ্ক অফ দ্য রোডস। তুমি তো আর উড়ে উড়ে হসপিটালে যেতে পারবে না, হেঁটে হেঁটে যেতে হবে, রিক্সা নিয়ে যেতে হবে, গাড়ি নিয়ে যেতে হবে, বা অ্যাম্বুলেন্স নিয়ে। So you have to think of the street networks now. So street networks এর ভিতরে দেখা যাচ্ছে এখানে street network এভাবে আসছে, এটার জন্য দেখা গেল সে এইভাবে চলে গিয়েছে, আর এটার জন্য ডিরেক্ট একটা রাস্তা চলে গিয়েছে। So now from all these examples, এখানে তোমার কি আছে, এখানে পয়েন্ট, সো তুমি কি অ্যাপ্লাই করলা, পয়েন্ট এন্ড দেন লাইন। ওকে, সো তোমার পয়েন্ট এই জায়গায়, এখন লাইন ইউজ করে তুমি লেংথ ক্যালকুলেট করে তুমি বললা অলরাইট দিস ইজ দ্য রাইট হসপিটাল, দিস ইজ দ্য নিয়ারেস্ট হসপিটাল অফ মাইন। এমন হইতে পারে যে তুমি যদি মানে ডিরেক্ট ক্যালকুলেট করো, এটা হয়তো 1.5 কিলোমিটার এন্ড অল অফ দেম আর হ্যাভিং 1 কিলোমিটার away from you, they are at 1 kilometer away from you, সবাই কিলোমিটার দূরে আছে, কিন্তু যেটা 1.5 কিলোমিটার দূরে ছিল, যেহেতু তোমার এখানে শর্টেস্ট পাথ অর্থাৎ যে রাস্তা চলে গিয়েছে সেটা ডিসটেন্সটা হচ্ছে মিনিমাম, এটা তোমার নিয়ারেস্ট ডিসটেন্সের হসপিটাল হয়ে গেল। কারণ এখানে গেলে তোমার ধরো 5 কিলোমিটার রাস্তা দিয়ে যেতে হবে, এটাতে গেলে 3 কিলোমিটার, এটাতে গেলে ধরো 4 কিলোমিটার রাস্তা পাড়ি দিতে হবে। সেই জন্য যেটা তুমি কল্পনাও করো নাই যে তোমার পাশে সবচেয়ে কাছে, সেটাই তোমার সবচেয়ে কাছে হয়ে গেল। So in this analysis, you cannot use raster. All you have to rely is, or all you can use is vector data. But then now you are trying to find out how the urban areas has changed over the years, or how economy is influencing urban development or urban expansion in Dhaka city. তো এটা যখন করতে যাবা তখন তোমাকে ইকোনমির, ওইটা তো একটা সোশিও ইকোনমিক পার্ট, ওকে, প্যারামিটার, ওইটা ওদিকে গেল। আমি ফিজিক্যাল জিওগ্রাফিক্যাল প্যারামিটার যেটা, সেটা হচ্ছে আরবান এরিয়া। সো আরবান এরিয়ার বাউন্ডারি তোমাকে মাপতে হবে। সো আরবান এরিয়ার বাউন্ডারি যখন আমি মাপতে যাব, তখন যদি আমি শুধু ভেক্টরের উপরে কাজ করি, ইট ডাজন্ট রিয়েলি মেক সেন্স, বিকজ ইটস আ কন্টিনিউয়াস ফেনোমেনন, ইটস আ ফিল্ড ফেনোমেনন। তো এই ক্ষেত্রে আমি তখন ভেক্টর ইউজ না করে রাস্টার ইউজ করব। সো ওই ক্ষেত্রে ভেক্টর ইউজ করাটা হচ্ছে বোকামি, রাস্টার ইউজ করাটা হচ্ছে চালাকের কাজ বা ওয়াইস। যেমন আমি তোকে খুব সহজ একটা এক্সাম্পল দিতে পারি আজকে। আমার এক স্টুডেন্ট, সে ডিটেক্ট করতে চেয়েছিল হচ্ছে ল্যান্ডফিল সাইট, যে ঢাকার আশেপাশে ল্যান্ডফিল সাইট কোথায় হবে। তো এটা করতে গিয়ে তার পুরো স্টাডি ঠিক ছিল, সে শুধু একটা জায়গায় ভুল করেছে। ভুলটা হচ্ছে সে ডাটাগুলো ভেক্টর হিসেবে নিয়েছে ইনস্টেড অফ টেকিং রাস্টার। সো যেই মুহূর্তে সে ভেক্টর করে নিয়েছে, এখন ভেক্টরের একটা পটেনশিয়াল প্রবলেম আছে। আমরা আরেকটু অ্যাডভান্স ডিসকাশন করে ফেলি তাহলে আজকে। সেটা হচ্ছে, টেল মি ইউ হ্যাভ ওয়ান ভেক্টর, দিস ইজ আ সার্কেল এন্ড দিস ইজ অ্যানাদার সার্কেল। এখন এই দুটাকে যোগ করো, কি পাবা? কি আসবে?
সার্কেলের এরিয়া, সার্কেলটা যে এনক্লোজড এরিয়াটা যোগ করতে হবে।
না না, এরিয়া না, তারা দুজনেই একই লোকেশনে লোকেটেড। আই মিন ফর এক্সাম্পল, আমরা দেখেছি কি, আমরা রাস্টারের ক্ষেত্রে দেখি নাই যে আমার যদি এখানে একটা পিক্সেল থাকে, এই পিক্সেলের ভ্যালু যদি হয় 5, একই লোকেশনে আমার আরেকটা পিক্সেল আছে যেটার ভ্যালু হচ্ছে ধরো 2, তো আমি দুটোকে মাল্টিপ্লাই করলাম। মাল্টিপ্লাই করলে আমি অ্যাজ এ রেজাল্ট ওই লোকেশনেই আরেকটা পিক্সেল পাচ্ছি, সেটাকে হচ্ছে 5 দুগুণে 10, যে পিক্সেলটার ভ্যালু হচ্ছে 10। তো এখন তুমি সেম টেকনিক ভেক্টরে ইউজ করো। আই মিন ওই যে লাস্ট এক্সাম্পলে মনে আছে যে ইন্টারমিডিয়েট তুমি জিজ্ঞেস করেছিলে যে এই দুটো যদি মাল্টিপ্লাই করি তাহলে রিয়ালিটিতে এটা থাকবে কিনা। আমি বলেছিলাম যে রিয়ালিটিতে থাকবে না, এটা একটা ইন্টারমিডিয়েট লেয়ার হয়ে যাবে। বাট দেন ইফ ইউ ইনকর্পোরেট আদার প্যারামিটার্স, সেক্ষেত্রে আমরা তখন ওই ভালনারেবিলিটি ম্যাপ এগুলোকে ইনকর্পোরেট করলে আমরা তখন রিস্ক ম্যাপ একটা পেয়ে যাচ্ছি। মনে পড়েছে? গত ক্লাস থেকেই তো মনে হয়, লাস্ট ক্লাসে আমরা এটা নিয়ে ডিসকাস করেছিলাম। তো ওখানে সবই কিন্তু একই লোকেশনে ছিল, রাইট? করে তুমি একটা ভালনারেবিলিটি ম্যাপ পাচ্ছ। নাও ট্রাই টু ডু ইট ইউজিং ভেক্টর, অর ইনফ্যাক্ট হ্যাভ দিস লাইন, একটা লাইন আছে আর একটা লাইন আছে, এন্ড দেন তাদেরকে মাল্টিপ্লাই করো, কি হবে? ইউ ক্যান নট ডু দ্যাট। ওকে, কেন করতে পারবে না জানো? বিকজ এক্স্যাক্টলি, সো দিস লাইন ইট মাইট হ্যাভ আ ভ্যালু, তুমি তার অ্যাট্রিবিউট টেবলে ভ্যালু রাখতে পারো, বাট সেটা অ্যাট্রিবিউট টেবলে আছে, এই লাইনে নাই। বুঝতে পেরেছো? এবং গতকালকে অথবা লাস্ট ক্লাসে আমরা দেখেছি কি আমাদের যখন রাস্টার গুলো ওপেন করেছি রাইট ক্লিক করে ওই যে লেয়ার থাকে তারপরে রাইট ক্লিক করে এভাবে অনেকগুলো মেনু আসছিল না
Yes,
মনে
sir.
পড়ে তো মেনুর এখানে কিন্তু অ্যাট্রিবিউট টেবলের ওই অপশনটা ফাঁকা ছিল রাস্টার ডেটায় মনে আছে আমি তোমাদেরকে দেখাচ্ছিলাম যে দি অ্যাট্রিবিউট টেবল গ্রেড আউট এটা ফাঁকা এখানে কোনো অ্যাট্রিবিউট টেবল নাই বাট যখনই আমরা ওই যে আইডেন্টিফাই টুল দিয়ে একটা পিক্সেলে ক্লিক করেছি তখন সে আমাদেরকে বলছে দিস ইজ
Identify করেছিল কোনটা কি।
built up area exactly so built up area বলছে so that means ওই রাস্টারের পিক্সেলের ভিতরেই not in the attribute table but within that pixel it's containing a value which is built up or others or vegetation ঠিক সেইভাবে এখানে এই পিক্সেলে সে কন্টেইন করতে পারে 5 2 and তখন তুমি দুইটা পিক্সেলকে যদি মাল্টিপ্লাই করো which are located at the same location then automatically it will create another layer or containing another pixel which is containing the multiplication value of the prior two layers যেটা এখানে করা যাবে না কারণ এখানে এই প্রতিটা লাইন কোনো ভ্যালু হোল্ড করে না তারা ব্যাকগ্রাউন্ডে এরকম একটা অ্যাট্রিবিউট টেবলে ওই ভ্যালুগুলোকে স্টোর করে রাখতে পারে তো ওই ধরনের অ্যানালাইসিস করতে গেলে তখন তো ভেক্টর ইউজ করাটা বোকামি সো দেয়ার ইজ নট রিয়েলি আ শর্টকাট অ্যান্সার অফ which one is